Hi everyone, this is Building Bytes. These episodes are excerpts from the Building Knowledge Base, available at info.building.inc. In these monologues, I will read research articles and thought leadership that we've published. If you learn something new, please consider following and leaving a positive review. Enjoy! Core concept number 1: Foundations of Asset Legibility. Asset continuity. Real estate assets accumulate value, risk, and meaning over time, making continuity of information essential to understanding and financing them. Overview. Assets continuity is the principle that real estate assets must be understood and managed as continuous systems over time. Value, risk, and compliance do not exist at discrete moments. They accumulate across design, construction, operation, and transfer. The challenge is not a lack of data. Buildings today generate more documentation than ever before. Digital models, sensor readings, maintenance logs, compliance certificates. Yet, despite this abundance, most assets arrive at critical moments: refinancing, sale, major renovation, informationally opaque. The problem is not volume, but persistence. Information exists, but it does not endure in forms that remain usable across changes in ownership, software systems, or regulatory frameworks. When continuity breaks, assets become harder to evaluate, finance, and trust. Uncertainty compounds. Stakeholders must reconstruct context from fragments, introducing delay, cost, and interpretation error. When continuity is preserved, assets remain legible. Their history explains their present condition. Their records substantiate their performance. This legibility is what separates assets that can readily demonstrate value from those that cannot. The structural problem of phase-based thinking. The real estate industry organizes work into distinct phases: design, construction, operations, transactions. This division is not arbitrary. It reflects genuine differences in expertise, liability, and economic interest. But phase-based organization creates a paradox. Each phase optimizes for its own success while treating information as a local resource rather than a durable asset. Consider a typical trajectory. A developer's building information model captures design intent with precision: spatial relationships, material specifications, system capacities. The contractor's as-built records document what actually got built, including field modifications made to resolve conflicts or accommodate site conditions. The property manager's work order system tracks subsequent alterations, repairs, and upgrades. The appraiser, arriving years later to support a refinancing, receives floor plans and rent rolls. The building's informational richness, the decisions, the deviations, the performance data, has been filtered out at each handoff, shaped to meet immediate deliverable requirements rather than designed to persist. This is not negligence, it is how the industry is structured. But the consequence is that the asset's informational integrity degrades even as the asset itself may be maintained immaculately. The building stands, its history dissolves. When that history is needed, and it is always needed eventually, it must be reconstructed at significant cost, or its absence must be priced into decisions as heightened risk. Why history is an asset, not an archive. A real estate asset is defined as much by its past as by its current state. Original design intent explains why systems were sized as they were. Construction decisions reveal where field conditions required deviation from plan. Modifications over time show how the building has been adapted to changing use or technology. Performance under actual operating conditions, not modeled conditions, demonstrates what the building can reliably deliver. These are not merely interesting details for historians. They are load-bearing information for anyone who must make decisions about the asset's future. Can this building support additional floors? The answer depends not on original drawings, but on whether subsequent modifications compromised structural capacity. Is this mechanical system approaching end of life? The answer depends on maintenance history, not just installation date. What risks does this asset carry? The answer emerges from understanding how it has responded to stress over time. When this history is preserved and structured, it becomes a strategic asset. It reduces the time and cost required to answer fundamental questions. It enables confident decision-making because stakeholders can rely on evidence rather than assumption. When history is absent or fragmented, every question becomes expensive. Inspections proliferate, contingencies widen, deals slow or break. Asset continuity treats history as infrastructure, not as an archival obligation. The difference is intentionality. Archives preserve. Infrastructure serves ongoing operations. A well-maintained informational infrastructure means the building can explain itself quickly, credibly, completely, whenever that explanation is required. The golden thread and what actually persists. Asset continuity depends on what regulatory frameworks increasingly call the golden thread of information, a continuous, traceable flow of reliable data across the asset's life. But this metaphor risks suggesting something purely abstract, a digital record that exists somewhere in the cloud. The real question is more concrete. What specifically must persist for an asset to remain intelligible over decades? 4 elements form the foundation. First, verified specifications against actual conditions. Not what was planned, but what exists, confirmed through direct observation or testing at known points in time. Second, audit trails of modifications and their rationale. Why changes were made, by whom, under what authority, and what approvals were secured. Third, performance data tied to specific systems and interventions. Not aggregate building performance, but system-level data that shows cause and effect. Fourth, compliance documentation with temporal validity. Evidence that the asset met applicable standards at the time those standards applied, creating a defensible historical record even as standards evolve. This is not about capturing everything. It is about capturing what cannot be reconstructed later and what downstream decisions depend on. The test is simple. If this information were missing, would its absence create uncertainty that affects valuation, risk assessment, or operational planning? If yes, it belongs in the golden thread. Continuity operates at the informational layer. Buildings persist physically even when information does not. A structure can be sound, systems operational, yet the asset informationally illegible because documentation has fragmented, formats have become obsolete, or the provenance of records is unclear. This is the paradox that asset continuity addresses. Physical durability does not guarantee informational durability. What breaks continuity is rarely catastrophic loss, a fire destroying archives, a flood ruining documents. Most commonly, continuity erodes through diffusion. Files scatter across systems. Formats become unreadable as software evolves. Knowledge resides in individuals who leave. The result is not absence, but fragmentation. Information exists, but cannot be assembled into coherent understanding without significant forensic effort. The cost of this fragmentation becomes visible during inflection points. A transaction requires due diligence, but documents are spread across multiple parties with unclear version control. A major renovation needs to understand existing systems, but as-built records conflict with maintenance logs. A refinancing demands evidence of compliance, but certificates are missing or their validity is ambiguous. In each case, the same pattern: physical assets intact, informational asset compromised, timeline and cost ballooning as stakeholders attempt to reconstruct what should have been preserved. Why digitization alone does not solve this. Digitization converts analog records into digital files, which is necessary but insufficient. Without structure, provenance, and intentional design for persistence, digitization can accelerate fragmentation rather than prevent it. Files multiply. Storage becomes cheaper, so everything gets saved, but findability declines. Redundant versions proliferate. Metadata is inconsistent or absent. The result is a digital thicket. More data, less clarity. Asset continuity requires that information be created and maintained with its future uses in mind. This means designing systems where data is structured for interoperability, tagged with provenance so its reliability can be assessed, and maintained through governance processes that ensure accuracy over time. The difference between a digital filing cabinet and a system of continuous information is the difference between having documents and having knowledge that can be confidently acted upon. Financial implications of broken continuity. From a financial perspective, broken continuity manifests as friction and discount. Lenders price information asymmetry as credit risk. When an asset cannot demonstrate its condition through verified records, underwriters face a choice: invest time and capital in extensive inspection and analysis, apply conservative assumptions that reduce loan-to-value, or decline the opportunity entirely. Each option has a cost. Extended diligence delays transactions and increases expense. Conservative underwriting reduces proceeds or increases cost of capital. Walking away represents opportunity cost for both parties. In all cases, the underlying cause is the same. Informational gaps create uncertainty, and uncertainty must be managed through either additional investigation or additional buffer. Assets with preserved continuity are easier to evaluate because they present evidence rather than requiring investigation. The difference is not marginal. Due diligence timelines compress. Underwriting becomes more precise because assumptions can be replaced with verified data. Pricing improves because risk can be assessed rather than estimated. Over an asset's lifecycle, these advantages compound. Each transaction or refinancing is faster and less expensive. Each major decision, renovation, system upgrade, lease negotiation, proceeds from a position of knowledge rather than conjecture. Continuity as accumulated readiness. Readiness for financing, sale, or major capital events is not created on demand. It accumulates through systematic information management across the asset's lifecycle. Each phase either contributes to continuity or creates gaps that must be addressed later. Design that documents intent clearly makes construction more efficient. Construction that captures as-built conditions accurately makes operations more effective. Operations that track performance and modifications methodically make transactions more straightforward. Attempting to restore continuity retroactively is possible but costly. It requires inspecting what could have been documented during construction, testing what could have been monitored during operations, and reconstructing rationale that should have been captured when decisions were made. Every missing piece of information represents work that must be repeated. Asset continuity is the recognition that preserving information as it is created is orders of magnitude more efficient than reconstructing it later. Why this concept matters. Asset continuity explains why real estate inefficiencies persist despite technological advancement. The industry has adopted building information modeling, Internet of Things sensors, cloud-based property management systems, and digital transaction platforms. Yet, due diligence remains lengthy, refinancing remains complex, and asset transfers remain informationally expensive. The constraint is not the absence of tools, but the loss of continuity between phases, stakeholders, and systems. Software platforms assume information already exists in usable form. They provide infrastructure for storing, analyzing, or transacting data, but do not address the structural causes of information loss. Misaligned incentives between phases, lack of standards for handoffs, and absence of governance ensuring persistent quality. When continuity is preserved, assets remain understandable. When assets remain understandable, they can be evaluated confidently, financed efficiently, and transacted with reduced friction. Trust, liquidity, and price discovery all depend on the prior condition of informational integrity. Asset continuity is not a feature of sophisticated real estate. It is the foundation that makes sophistication possible. Without it, even the most advanced analytical tools and financial structures are building on unstable ground.